Welcome everyone. I'm Neil Fortner, Chief Architect of HDF5 at the HDF Group. Right now I'm going to talk about the architectural documentation document that we've been working on, and we're planning to have complete by the end of the year. And so I'm going to show what we have and also invite feedback on if you think the direction is okay and what you think is most important that we cover with the remainder of time we have to work on this document. So to start at the top, so sort of like a quote here explaining what we mean by architecture, but again, I'd like to hear other people's ideas about what they think would be most valuable. So at the top, of course, is the list of contents, but we're just going to go through the whole thing, so we don't really need to look at this now. We'll see it as we're going through it. So introduction. So first, this is maybe the most important part of the document right now for for presenting the overall aim. So it's so here we're these 4 bullet points are who we think the main audience for this document will be. So it's first is community contributors, anyone who wants to add a new feature or fix a bug, and if they want to hack on the code and send us pull requests, we believe this would be useful for anyone that wants to look in the code. And similarly, new library developers working at the HDF Group, or if their job is to work on HDF5 elsewhere, who are trying to get on board and so that they can start working on the code quicker. And also developers of HDF5 library extensions, such as vol connectors or file drivers or filters or new data types or what have you, that want to sort of have a better understanding of how things are working and how they can best optimize their plugins. And finally, power users who just want to have a better understanding of how everything is going on under the hood. And feel free to interrupt me if you have any thoughts on if you think that those categories are wrong, or there should be another category, or anything else that you want to raise while I'm talking. There's sort of 2 main, as we say here, there's sort of 2 main sections of this document. There's a guided tours in the reference section, and the guided tours are sort of, for the most part, higher level, and they go on, they describe what happens on through a specific code path, and the reference section is more in-depth, and it talks about sort of the specific packages or modules within the library, data space or data set or object. So here we sort of talk a little bit about what we feel architecture means. In this section, it kind of talks a lot about it's a very high level. It talks about how HDF5 is sort of a stateful model. And sometimes the map between input and output can be confusing. There could even be things like an input might like if you call a read operation, that might actually cause a write under the hood, because the read could fill up the metadata cache, and then it needs to evict something, so it flushes some things to disk. So it's very unlike a functional paradigm in that sense, in that while it's deterministic, it's not. It's very stateful. Largely because of the caches. Here it's sort of purpose objective values of HDF5. Main objectives are self-describing data and portable data, and of course we also try to make it performant. And this section's kind of explain the philosophy of HDF5, and more values here: compatibility, longevity, stability, efficiency, maintainability, progressiveness. I guess that's future proofing, and finally free software. Of course, it's open source software. All right, so here are the guided tours. So I think we have 8 tours outlined right now, but only 2 are sort of filled in all the way, and a few others are sort of have a more in-depth outline. So this first one, meet the HDF5 library. So this is sort of like, another high-level diagram of the architecture of the library, although it's kind of like more the architecture of the different, it's mostly the architecture of the different pluggable layers for some of them, because, most of the reference section is talking about just this block in here, the native vol. So then it talks about, vol, and then here, this tour goes into a lot of detail about the mechanism for library initialization and shutdown, which is somewhat complicated. And it goes to, a description of call graph, where the call graph figure went. There used to be a figure showing the call graph, but I'll have to dig that up. But yeah, so it goes into the code in the actual HDF init library. So this is one place where I thought that the tours is sort of, it's mostly higher level, but like places like this, it goes to a pretty low level, going into the actual lines of code here. And yeah, more details on the code flow in HDF init library. And so I guess this was put first because it's sort of like a hello world thing. This happens if you, just call something like HDF get lib version. That doesn't really do anything. It still calls all this initialization stuff. And then the second core is lifecycle HDF5 files, which is mostly like files themselves, like HDF5 file objects. So, and a lot of this is also about the vol connectors, because, when you open a file, that's when the first time it sort of figures out which vol it's going to use for that file. So if people aren't familiar with vol on this call, it's the virtual object layer. So just because we're talking about that, I'll give a little context here. So here you have the HDF5 API, HDF create, HDF create, things like that. And then those API calls will get the ones that will touch a file, like HDF create, will go to the virtual object layer, which is sort of a pluggable interface where by default it goes into the HDF5, what's called the native vol, which is basically the library that we all know and love, that's been around since 2003. And or was it 1998? But it's also possible to develop other pluggable vols that they essentially just take these HDF5 API calls. They're transformed a little bit but for the most part, they're just passed straight through to the vol connector. And then the vol connector translates those API calls into storage. And it could be, it could be just going straight to storage and storing it any way you want. In this case, for the Deos vol, it's an object store that has almost no relation to the HDF5 file format, or in this case, it could do something with it. In this case, make it asynchronous and then pass it down back into the native vol or a different terminal vol potentially. And then the virtual file layer is another pluggable layer that's similar, but it goes under the native vol, and it translates the offset length and buffer, read write calls to the actual storage, to the actual, the low level for example, it might be POSIX read write calls, or for the split file, it splits it into different files depending on the type of file, but it has no knowledge of the or very little knowledge of the actual structure of the HDF5 file. All it knows is offsets and lengths and buffers. All right. So back to the lifecycle. So yeah, a lot of this is ends up being describing how the vol layer works internally, and we'll go more into that in the reference section. And again, he calls it a detour here. There might be more to come for this tour, but right now most of it is about vol connectors. This is about how vols connectors are loaded, etc. And then here it talks about the virtual file layer, like I talked about before, the file drivers, which is another pluggable layer that goes under the native vol. And you could presumably also use it with a non-native vol, because we have public hooks into the virtual file layer. All right. So I guess we need to. So the third tour is called "What is the HDF5 library doing to my data?" And this is more. This is just kind of outlined right now, and it's about data sets and how the data that you want to write to disk is actually transferred to disk and retrieved eventually. Then getting down and dirty with caches, that's about metadata cache and different raw data caches that we have, and about things like how do you know when the data actually hits the disk. Stoked on data types, which is, you can imagine, about data types, and this has a little bit more written because we want to get down some thoughts about committed versus non-committed data types, because that's kind of a common wrinkle that library developers run into, is like how the different ways that committed versus non-committed data types are handled, and how it kind of links two disparate sections of the code together in a weird way, by linking together file objects with sort of transient in-memory data types. And also there's the serialized data type messages, and it just gets kind of tough. So that's why there's some more written about it here. Are parallel HDF5 good with at MPI multitasking? So obviously the titles get a little fun, but so this is about parallel HDF5, and also I believe it also covers okay, I guess it's just parallel HDF5. I was thinking it covered thread safety, but I don't think it does. And there's another okay, yeah, this is multi-threading and asynchronous IO. So this talks about how we have an asynchronous IO API, but it's not implemented in the native connector right now, and also about how the thread safety works right now, and it's going to go into more detail about what the advantages and disadvantages of implementing asynchronous IO versus implementing concurrent thread safety in your vol would be. Then, I guess there's more than 8 tours. Okay, so then there's a tour about attributes that doesn't have anything there yet, and H stands for hierarchical, which I guess is about the group structure. All right, so then we get to section 3. So then we have the vol architectural elements, which we're still, so this is one thing that we'd like to get feedback on. We're still kind of going back and forth about what this section is supposed to be and how it's supposed to be distinct from the tours and the reference section. But it's, I think the idea that some of us have is it's supposed to be more abstract and less tied into how the actual code works. But we'd like, if anyone on this call has any opinions on what sort of an in-between level of documentation would be, then feel free to speak up. And architectural problems, so current issues that sort of long-standing code architectural issues that would ideally be addressed at some point. We only have 10 minutes left. Okay, so then we go to the reference section, which is sort of the low level, well, low-ish. I mean, it's still somewhat high level. It's not to the level of comments. Try not to get so deep in the weeds that we're just basically rehashing what the comments say. But we're trying to be a little bit higher level than that and sort of make it easier to sort of understand the big picture so that you can go in, and when you read the comments, you have a better idea of how that sort of fits into the overall way things work. So yeah, it's mostly just kind of laid out by code packages, H5C, H5D, H5E, etc. But some of them are combined to some degree. So we have handles and IDs is somewhat outlined a bit. And we have file objects has quite a bit written for it. This is all text. I wasn't sure how to diagram this out, but it explains what how objects are represented in memory, what object headers are both on disk and in memory, and object header messages, which for those that don't know, so HDF5 objects like groups and data sets are stored as an object header in the file, and the object header has some metadata at the top, that's in all object headers, and then it's also sort of a flexible, I guess you could call it an extension feature, or like a flexible metadata storage called object header messages, which is just a list of different types of metadata, and there's like 20 different kinds in the file format. And some of these object header messages determine, for example, among other things, they determine whether it's a group or a data set or a committed data type. And they store other data as well, including like attributes. So this talks about how the object header messages are handled, and then we'll also talk about shared object header messages, which is a mechanism to save space by when the object header message is duplicated between multiple objects, it'll only store it once if the feature is enabled. But some of the code for that ends up being kind of hard to follow, and it wasn't really documented anywhere, so I documented it here. I haven't written anything for object copying yet. And we have a little bit of outline for attributes, groups, and links. Started writing for data sets. Haven't gotten much yet, but we have quite a few sections outlined. And data types. So this is going to be more sort of in-depth discussion of how the data type code works versus the tour is more conceptual, I guess. But it's a bit of a fine distinction because this is still, it's not, as I said before, it's not aimed to be, for the most part, at the actual code lines of code level. It's a little bit higher level than that, sort of explain the code flow. And so there is still trying to figure out exactly where the distinction should be between what goes in the tour and what goes in the reference. But again, it is meant to be higher level in the reference and lower level in the tour, or no, higher level in the tour and lower level in the reference. Data filters and data spaces. I think I more or less presented this at another call to the doctor a while back. And this section might actually be useful for, well, yeah, this one could be in particular useful to power users and Vol developers, because some of the like selection or partial IO stuff is can be a bit tough to wrap your head around when you're developing a Vol plugin. So this sort of makes it a bit easier, or a bit easier to understand, what needs to happen and how things work. And property lists. We're planning to have these for every package, the list of source files. Though I think we need to fix the formatting here. And here we're talking about the different plugins, pluggable layers. Here we listed filters like data filters, data pipeline filters, vol connectors, and file drivers. Be a section on the vol that covering things that weren't covered before. Section on event sets and asynchronous IO. Again, covering things that weren't covered before, sort of like more the code, like the mechanisms for how things work. And then sort of short section on just a few words about each of these things that are just kind of machinery that's used for specific tasks within the library. Then plan to have some performance like best practices, other performance considerations. We haven't written anything yet. And we have another section on extensions, and I'm not sure how that's really different from the one in reference, but or the other or the different tours. But yeah, again, if anyone has any ideas on like what how we should delineate this in all layers. So yeah, here, so the extensions include the ones that were in the pluggable layers, but also these other user-defined things that don't go through the like the pluggable layer HIPL, like the dynamic library loading thing. Then we have another section sort of on the nuts and bolts of parallel HDF5. Again, same question there, because we already had the parallel tour, but we don't have a parallel reference, so maybe this has more usefulness. Epilogue, a little blurb from Mark Miller there. Okay, then we have in the appendix a list of packages. So there's a list of all the different packages in the HDF5, which could be, useful for, what does this two-letter thing stand for? What does it mean? Oh, this is sort of a graphic showing the dependencies between different packages. And I forget which one is which, but we'll make sure to write that. But you can see like the H5, like, so I think this means that H5A depends on H5CX. So a lot of different things. So, okay, yeah, everything depends on H5E, but H5E doesn't really depend on very much. So yeah, because everything throws errors, so they depend on H5E. And this is incomplete, but we have a list of different major features and what versions they were introduced in. We're planning to have expand this, but this is a matrix of what features are compatible, are able to be used together. So another sort of diagonal, well, I guess the other one was not diagonal, but this is sort of a diagonal matrix right now with a few different nodes too. Okay, so a section on how VFDs can be stacked together, what the allowable stacking options are, and same for vol connectors, although that's more that'll be more general because we can't, really we're probably not going to try too hard to document code that is from outside the HDF group. Environment. Yeah, so this goes into yeah, I guess this is Yeah, I'm not sure what this is. It's calling it, looking at a call graph for something or other. I think it was this. I think this might be what I thought was in the first tour, where it's going to a call graph for what happens just for initializing the library. Yeah, it looks like that. Yeah, I don't know why this is down here. And we got stories. I was reviewing it. I guess I didn't get this far. Oh, I guess we're out of time. So does anyone have any comments or questions on what we're doing so far?
Is this just an internal project, or like, are you getting input from like Mark Miller and stuff?
We're getting input mostly from the ECP folks. But we'd like to have input from anyone. If anyone, so right now this is on Overleaf. We're hoping to get it into the GitHub sometime soon, but it's not there yet. But if anyone wants to take a look at it, just feel free to email me and I'll send you a PDF with the current status of the document.
Yeah. Hey, Neil, this is John. I was curious, does the document go any detail about how region references are defined?
It will. Yeah. So let's. I'll have to check the data type tour. So let's look at the data type reference. Yeah, so there's the bullet for reference data type, so I'll go into some detail there. Are you more interested in how it's defined, how it's stored on disk, or how it's handled in memory or during I/O?
Yeah, all three, I guess. Right. I mean, to the user, there is kind of like an opaque
Right.
thing. Right?
Right.
It's kind of
Yeah.
interesting to see what's underneath.
Right. And we'll probably have to talk about old versus new references. But yeah, we'll talk about that. And let's see, there's enabling. Yeah, I guess there isn't anything about region references in the tour yet, but that should probably be added for complete sake of completion.
Okay, cool.
Anything else? All right. Well, thanks for coming then. I guess we'll see everyone next week.
Great. Thank you, Neil. Bye, everyone.
Thanks.
Bye.